Hey everybody, it is Mr. George, and next thing we're going to do is we are going to review some math, and then we're going to work through about 15 math problems. So before we get into the math word problems, those are the types of math problems we're going to look at tonight. Let's just review the concept of place values. So if you do have your student book with you, this appears on page 181 if you have it. And if you don't, you can just follow along. So when we say place values, we're looking at numbers, and each number represents an actual value. So you can see that the decimal point for this number right here is right here in the middle. So this number would read 5,128.375. So each one of these numbers or each one of these digits has a value because of its location or place in relationship to the decimal point. So if we start at the decimal point and we come to the right, 3 is in the tenths place. 7 is in the hundredths place. 5 is in the thousandths place. So when we go to the right of the decimal point, we are less than 1. Less than 1. And these values, these decimals, can also be represented as a fraction, which we'll look at an example in a minute. As we go to the left of the decimal point, we have 8 is in the ones place, 2 is in the tens, 1 is in the hundreds place, and 5 is in the thousands. Now we normally just put a comma every 3 digits for readability. It makes it easier to see when we have commas after 1,000 or 10,000 or 100,000 or a million. That way we know exactly where these place values are. So if we look down here, I wrote the same number and I put the place values to the left. And let me just scroll this down here. So if we look at this, we have 5 is in the thousands. So if we actually took this example, this number, and we said, okay, 5 times 1,000 because it's in the thousands, and then we add 1 times 100 because it's in the hundreds, 2 times 10 because the 2 is in the tens column, 8 times 1, and then we add 3 times 0.1, which represents tenths. 7 times 0.01, which represents hundredths, and then we have 5 multiplied by 0.001 that represents the thousandths. If we multiplied those and then added the products of each of those in parentheses, that would give us our answer of 5,128.375. If you want to keep it real simple, if we just looked at the example of, say, 28, you would see 28 is really 8 ones and 2 tens. That gives us 28. 2 times 10 is 20. 8 times 1 is 8. We add them together. That would give us 28. So that's place values. And the second concept, which is on page 182 if you do have your book, is the concept that does connect with decimals, and that's fractions. So in class, we've looked at decimals and fractions, which connect with percentages. So those three all really fit together. So let's look at an example of a pizza with 8 slices. So there are 8 total slices, and each slice is shaded in. So when we talk about a fraction, we're really talking about a part divided by the whole. So the top number is referred to as the numerator, and the bottom number is referred to as the denominator. So when we say 8 divided by 8, or 8 over 8, we're really taking the top number, we're dividing it by the bottom number, and it's going to give us a number. If the top number is the same as the bottom number, then the answer is 1. 8 divided by 8 gives us 1. And I'm just going to make this a little bit bigger here. Oops. Okay. So if we look at the second example, we have another pizza. We have 8 slices, but this time only 4 out of the 8 slices are shaded. So again, the top number is the numerator. This is the part, so that's the 4. And then the 8 is the whole, which is the 8. So 4 divided by 8, or 4 over 8, or 4/8. Now, when we talk about fractions, we want to reduce a fraction to the smallest number that is equal to or equivalent to it. We want to reduce the fraction. So if you had a pizza and you ate these 4 slices and someone said, how much of that pizza did you eat? You probably wouldn't say, I ate 4/8 of the pizza. You would say, you ate half of the pizza, or 1/2. How do we do that? Well, 4/8, to reduce a fraction, first of all, if they're both even numbers, you know that 2 will go into each one of them. But you want to find the biggest number that will go into both of those numbers. So looking at 4/8, I know that 4 can go into 4 one time, and I also let 4 goes into 8 twice. So 4/8 equals, or is equivalent to 1/2, or 1/2. Now, when we divide 1/2, I did the division right down here. 1 divided by 2 as a decimal is 0.5. 0.5. So when we talk about decimals and fractions, that's 2 different ways of representing the same number. And in a previous class, we looked at percentages. That's another way. So if I said 1/2 equals 0.5, which is the same as 50%, because I'm taking the 0.5 and I'm multiplying it by 100, which really means I'm moving the decimal point over 2 places to the right. Okay, so we have fractions, which show us 2 numbers apart over the whole, which is the top divided by the bottom. We want to reduce fractions to the smallest equivalent fraction. And then when we divide the top number by the bottom number, it will give us a decimal, 0.5. We know based on place values that the 5 is in the tenths place value. And then to get percentage, we take the 0.5, we multiply it by 100, which really means we move the decimal point 2 places to the right, and that would give us, in this example, 50%. Good. So that is the review of place values and looking at fractions, reducing fractions to the smallest equivalent or equal fraction by finding the biggest number that can be divided into both the numerator and the denominator. And then the last step would be to create a percentage. We take the decimal point and we move it 2 places to the right, which really means we're multiplying it by 100, and in this example would give us 50%. Thanks for watching.